Welcome back, everyone. This is Mr. Wakefield again, looking at the second half of our mixture problem worksheet. And in the first part, we did a couple problems that involved this formula right here, TPA. And that involved when we had a mixture problem where we were mixing together two different things that had a percentage subquantity. Okay, two different liquids basically, okay, where they had a little bit of, for example, maybe 50% antifreeze or 20% antifreeze, where the rest of the liquid was something else. For example, 50% antifreeze means that the other 50% was water or chemicals or something like that. And so each of the two items we were mixing had a percentage subquantity, like 50% antifreeze or 75% acid, those kinds of things. And that's when you use this formula here. In the second half of this worksheet, however, we're going to be mixing together two things once again, but this time we're going to be mixing together two things that have a cost per attached to it. Now, what do I mean by cost per? I mean, for example, cost per pound, $1.20 per pound. That's cost per pound. Okay, you can see other ones in this problem as well. $1.80 per pound. Again, that's cost per again. And in particular, it's cost per 1 pound. It does not say cost for 5 pounds or cost for 3 pounds. No, it says cost per pound, meaning just 1 pound. All right. So if you have two different things in your problem that are mixed together and they both have a cost per attached to them, like $1.20 per pound or $1.80 per pound, then that's when you want to use this other formula here. All right. And we're going to abbreviate it as A times C equal to TC. What that means is and that can be kind of confusing because you can see here that the C means cost, but the TC means total cost. I've got the more written out version of it right here, as you can see. And so that can be confusing because cost and total cost, they sound pretty similar, right? So let's make sure that we understand exactly what each of these three parts means. So I wrote it out here a little bit bigger on a scratch sheet of paper. Again, you don't have to write down what's on the scratch paper, but you can if you want, certainly. But basically, when you're mixing together two things that have a cost per attached to it, I want you to start out with that. All right, once you notice that you're mixing together two things with a cost per attached to it, I want you to realize that if it's cost per pound, then the A over here has to be the number of pounds. Okay, these two words must be the same. So for example, if this had said cost per ounce right here, then this would have to be the number of ounces. Cost per ounce, number of ounces. It has to be that same word right there. Okay, the amount over here is never money. This is never money right here. Okay, it's always the number of items. In this case, the number of pounds, or if this was per ounce, then this would be the number of ounces. But this is never money. Okay, these two things are money. Okay, so now how are we able to tell these two things apart to make sure that we don't get that mixed up? Okay, the way that works is like this, and the best way for me to show you that is to show you an example. So let me open things up here. There we go. Let's say, for example, in this same situation with $1.20 per pound, let's say I want to buy 5 pounds of that particular candy that they were talking about. So what you do is you put the 5 here then for where the A is, and then you multiply that by the $1.20 right there. And then obviously you want to put down your calculator and multiply that together. If you multiply those two things together, it's going to be equal to 6, exactly 6. Okay. So it says total cost of all the pounds. What that means is that if you buy 5 pounds, which I indicated right here, then the $6 is going to be the total cost of all 5 of those pounds. So if I put 7 pounds here and I multiply that, then whatever that's equal to, and it's going to be $8.40, that is going to be the total cost of all 7 pounds. All right, so however many pounds you have here, that is the total cost of all of them. So the difference between these numbers over here versus these numbers in the middle is that the numbers in the middle are the cost for 1 pound, but this is the total cost of all of the pounds. How many pounds? Well, it depends on what the number is over here. But the thing in the middle is always the cost of just one single pound, okay? Just one, whereas this is the cost of however many you have over here, that many pounds. Okay, so that is the difference between these two. And then the amount, that's just the number of items that is indicated by whatever's after the word per right here, okay? So per pound, then amount would be the number of pounds. Okay, so we are now, once again, like I said, we are going to be mixing together two things that have a cost per attached to it. Let's jump right into the first problem here and see how that works. It says, Mariana wishes to blend candy selling for $1.20 per pound with candy selling it for $1.80 per pound. So she wants to mix those two things together. Blend and mix mean the same thing, right? To get a mixture that will be sold for $1.40 per pound. How many pounds of the $1.20 and the $1.80 candies should be used to get 45 pounds of the mixture? Okay, again, how many things are they asking us for here, and what are those things that they're asking us for? Let's see. It says here, how many pounds of the $1.20 and the $1.80 candy? So they want to know what? They want to know the pounds. Again, don't just say $1.20 candy. Be specific. They want to know the number of pounds of the $1.20 candy. And they want to know the number of pounds of the $1.80 candy. That's what it says, right? How many pounds of the $1.20 and the $1.80 candy? All right, so we have, therefore, two variables, two things to find here. We are still going to use the 3 rows and the 3 columns like we did in the other mixture problems from the previous video. The reason why is because we once again are mixing together two things, okay? And we still have 3 parts to the formula that we're using, and so therefore we need 3 columns, okay? This time the formula is ACTC. Again, we use this formula when we're mixing together two things that have a cost per attached to it, okay? So once again, we put the mixture on the bottom like we did in the other mixture problems from the previous video. And then you take the two things that are being mixed, which are the $1.20 candy and the $1.80 candy. Okay. We take those two things and we put them in the first 2 rows. Doesn't matter which one is where, as long as these two things are on the top, and the mixture definitely has to be on the bottom, just like before. Okay. And as long as you do it that way, you can still do those same things that we did in the previous video, where you can add down on the first column and the third column. Not on the second, but you can add down on the first and the third here. Okay. So let's get into it here. As usual, we want to start out with the first column and work our way over. Let's see what we can fill in here. It says the amount. Now, what is the amount? Well, it all depends on the problem. Since this is a cost per pound problem, then that means that the A is what? It is pounds. All right. Again, if this had been cost per ounce, then the A column would be the number of ounces. So what we're being asked to do here is that we want to know the number of pounds of the $1.20 candy, the number of pounds of the $1.80 candy, and the number of pounds in the mixture. Okay. We don't know what the amount of pounds is for the $1.80, the $1.20 and $1.80 candy, but we do have a variable for those instead, and so we use that. Now, for the mixture, we do know what that is. Okay. Now, just to let you know up here, remember up here, we didn't know what this box was equal to. If you don't know what this box is equal to, then you can fill it in by adding down, since you're allowed to add down on the first column. Whereas on this problem, we did know what it was, so don't add down and say x plus y right here. Put 120 in there, okay? If you know what the box is equal to, put it in there. But if you don't know what it's equal to and you don't have a separate variable for that box, then you can add down here to fill that in, okay? And so that's the thing here. We do know what this box is equal to, same as the 120 right there. We know what this box is equal to. They tell us that the mixture is 45 pounds. So don't say, oh, this box here is equal to x plus y. No, put the 45 in there, okay, if you know what it is. The second column is the cost per. Okay, so this is what? This is per pound. Okay, so do we know the cost per pound of each one of these things? Yes, we do. We know that this is $1.20. Okay, you don't have to put the dollar sign in there. We'll save that. That's something that, again, you only need to do the units of measurement normally at the end of the problem. So 1.20, 1.80. Okay, that's the cost per pound of these two types of candies. And then the cost per pound in the mixture is going to be, it says here a mixture will be sold for $1.40. So that's going to be 1.40. And then, like we've seen so many times before, this won't always be the case all the time, though, but usually these boxes are boxes that you don't know what they're equal to. The variables have already been used up on something else, in this case, these two boxes here. And so that last option that you have is to use the formula to multiply across. Okay, first box times second box equal to the third box. Like this. 45 times 1.40 is 63 in your calculator. Okay. Now, since we have two variables and since we filled in all of our boxes here, since we got two variables, that means we need two equations. Like I said before, we're allowed to add down on the first and the third column. Both of those columns will give us legitimate equations here. They're not identities where both sides of the equal sign are exactly identical. All right, they are legitimate equations instead, and here they are. Okay, so I'm just adding down first box plus second box equal to the third box. Same thing on this column as well. I get these two equations here. Now that I've got my two equations, I could do either substitution or elimination. I'll go ahead and do substitution here. You could get either the x or the y by itself. All right, either one is about the same as far as how difficult or easy it is. I then plug it into the other equation as usual. Let's see how this comes out. After I plug it in, I then solve that resulting equation. Have your calculator close by to help you out here. 1.20, distribute that through here. We get 54 minus 1.20y. And then on that next step, we're going to combine like terms. So we need to combine these two together here. And we get 54 plus 0.60y. I then need to what? Let me just rewrite the problem up here. Okay, let me zoom in a little bit there. It got kind of small. There we go. I need to move over the 54 with the 63. So I get 0.60y is equal to 9. I then divide out. And I'm going to get, in my calculator, 9 divided by 0.60 is exactly equal to 15. I then plug it back into this equation right here to figure out the other variable. Remember, you got to figure out both variables, right? When you're doing substitution or elimination. And I get x is equal to 30. Now that I know what both of my variables are equal to, as I always do when I have to figure out two variables in a word problem, I then figure out how it's measured. 15 and 30, how are those measured over here? They are measured in pounds because it tells us that x and y are both measured that way. But you also got to tell me which one's which. Okay, you could tell that the difference here is that one of them is $1.20 and one of them is $1.80. So just tell me which one's which. All right, so the X was 30 and the 30 is the $1.20. So that must mean that the 30 pounds is the $1.20 candy. Okay, and then the 15 pounds must then be the $1.80 candy then. Okay. So again, we are mixing together two different things that have a cost per attached to it. Okay. Very similar, though, to the other mixture problems from the previous video as far as how the box is set up and everything. It's just that we're using a different formula. Okay, that's the main difference. All right, but you can still add down on the first and the third column, okay, which is very helpful. All right, let's keep moving here to the next one. There's going to be a slight difference here on the next one as far as how the problem looks, but it'll end up being similar, though. In this next problem here, we're not literally mixing something together, but we're purchasing two different things that have a cost per attached to it. We're purchasing them together. We're taking them both up to the cashier together at the store, for example. Okay, example of that is right here. Trang bought two different types of tea. So he's going to buy them both at the same time. Okay, the first type costs 85 cents per pound. Notice it says a pound, but 85 cents a pound is the same thing as per pound, isn't it? Okay, so we have cost per pound once again in this problem. The second type is 90 cents per pound. The total bill was $8.80. That right there is proof that he bought them both together. And so even though we're not literally mixing them together, okay, like we would mix candy together in like a bowl of candy, for example. You stick a couple different types of candy in a bowl. You're mixing them together. You don't have to mix these together in order to do this problem the same way we did the last one. You just need to buy them together as a group. Okay. And the next four problems are all going to be like that, where two different things with a cost per attached to it are going to be purchased together at the same time. Okay. And in each case, we're going to have this total bill, the total cost of everything, okay? And that proves that we're buying them together. That's how you know that you're buying them together, and that's what's going on. Okay, so what are we trying to find? It says how many pounds of each type. What do they mean by each type? Well, there's two different types, right? So that means we need two variables, one for each type. Okay, but it says how many what? Not how many tea bags, right? No. It says how many pounds. So again, let's be specific here so there's no doubt as far as what we're trying to find. It's the pounds of what? It's the pounds of the first type, which again, I'll be specific here and call it the 85-cent tea because that's how to describe the first type right there. And the second type is 90 cents, so I'll call that the 90-cent tea. All right. Step 3. So once again, since we are buying two different things together that both have a cost per attached to them, we're going to use that same formula as we did in the last problem, A, C, T, C. A times C equal to T, C. All right. What are we mixing? Or what are we looking together? I'll call this the together row. You can still call it the mixture row. That's perfectly fine. I just like to call it the together row now, just because that's more indicative of what's going on. Okay. We are now buying them together, so that's just what I call it. But mixture together, it pretty much means the same thing. What are we mixing or buying together? It's the 85-cent tea and the 90-cent tea, and so that's why I put those in the first two rows. It's the two things that you're either mixing, or in the case of a problem like this, you're buying them together. All right. Before we go any further, though, we need to make a decision here, because notice in this problem that some of the money discussed in this problem is in cents, but then right here there's a dollar sign. 8.80 with a dollar sign in front of it, that means that this is $8.80. So you've got cents here and you got dollars here. You can't mix those together like that. You can't use cents in one part of a problem and dollars in another. So what you need to do instead is you need to either convert the cents to dollars, or you need to convert the dollars to cents. And let's talk about that. If you want to convert from cents to dollars, okay, you need to divide by 100. In other words, you would need to do, if you want to convert the cents to dollars here, you'd have to divide this by 100, which would make it 0.85. Or if you want to go the other way, if you want to convert this one from dollars to cents so that it'll be the same as the 85 cents and the 90 cents, you could do that too. All right. In that case, you would do the opposite, as you can imagine, which would be to multiply by 100. So if you want to convert this dollar amount so that it's cents like the other two numbers are, then you multiply this by 100. And if you do that, okay, I'm going to go ahead and do it that way. But you could do it the other way as well. 880 cents. Okay. But you can't put these three numbers into the problem as they are because a couple of them are cents and one of them's dollars. That's not allowed. Okay. So if you had done it the other way, you would have had 0.85 or 0.85, same thing. You would have had 0.90 right here, and you would have kept this the same since this is already in dollars. Okay, but the way I'm doing it is I'm going to do 85 cents, 90 cents, and 880 cents. Okay, no matter which way you do it, it'll come out the same answer in the end. No doubt about it. They just all need to be the same thing, either all cents or all dollars. Okay, let's get started here. You need to do that, though, before you start putting the stuff in the boxes, all right, because the boxes need to, they need to have the correct numbers in them. So amount, remember, since this is per pound again, that means that the amount column is the pounds column. Do we know the amount of pounds of 85 cent tea? No, we don't, but we have a variable for it. Okay, it's X. Same thing with 90 cent tea. We don't know actually what it's equal to, but we have a variable for it. Okay, do we know the amount of pounds of all of the tea that he bought altogether? Yes, we do. It says here that the total weight of all the stuff he bought was 10 pounds. Okay, since this is the pounds column, that's where you'd put the 10, because the whole thing is 10 altogether. All right. So the two things together go down here. Part of why I said together here, right? Then in the next column, this is something else that's new. Listen out for that here in a second. But let me go ahead and start filling this in first, though. The cost per pound. Cost per pound of this column, all right, for the 85 cent tea, it's 85 cents per pound, and so that's why I put 85 in there. This is 90 cents per pound, and so I put the 90 in there. Now this last box, let's talk about that for a minute. Sometimes we just don't know what this is equal to. They don't tell us what it's equal to. We don't have a variable for it. Okay, now usually there's like an alternate way that we can fill that in, okay, whether it be multiplying across or adding down. But as I told you guys, you can't add down on the second column, and you can't multiply across because we don't have two things to multiply here yet. So here's the thing, you guys, listen closely. And this is only going to happen with this box here. Third row, second column. Only that box. Every other box should always be filled in. Okay, there's always going to be a way to fill in all the other boxes. But just the third row, second column, that box here, okay, if you don't know what it's equal to, and you don't have a variable for it, you can see we used up our variables on these two things, then you are allowed to leave that blank. Oh, but doesn't that mean that we can't multiply across? Yeah, it does mean that. But that's okay. We'll still be able to get what we need. Don't worry. But no, you won't be able to multiply across. Don't try to when this is blank. So again, don't leave this blank if you know what it's equal to. Don't leave this blank if you have a variable for it. But if neither one of those things is true, you don't know what it's equal to, you don't have a variable for it, leave it blank. And again, I'm just talking about third row, second column. No other boxes. Okay, just that one. Every other box should be filled in. So we go to this last column. I don't know what these two are equal to. Okay, they don't tell us. I've already used up my variables on something else. So as the last option, I can multiply across. Oh, but I can't multiply here. Yes, that's true. But that's okay because remember, you're not supposed to multiply across anyway if you know what this is equal to already. And we do. We know that the total cost altogether, total cost altogether is equal to 880 cents. Same thing as $8.80, which is the total bill. Okay? And so you don't need to multiply across if you already know what this is equal to. It's just when you don't know what this last column is equal to and you don't have a variable to put in there, okay, that's when you multiply across. But you already knew this. It's 880. Once again, I have two legitimate equations here from the first column, x plus y equal to 10, and from the last column, 85x plus 90y is equal to 880. And that's all you need. You just needed two equations with your two variables in it, right? Okay. So what I'm going to do here is do substitution again. I'll be different from the last one and get y by itself. This time it doesn't matter though. Okay, you could get x by itself. I then plug it into the other equation as always. There we go. And then solve that equation. 85x plus, and then we distribute here. 900 minus 90x. After we distribute, what do? We combine like terms. And so that's negative 5x plus 900 equal to 880. You then move over the 900 with the 880 so that you can then get the x term by itself. We get negative 5x equal to negative 20. Again, calculators are very helpful here, as you can imagine. Then we divide out and we get x equal to 4. As you guys know, after you solve one variable, you plug it into this equation right here at the end of step 1 of the substitution process to then solve for the other variable. Remember, we learned that when we did the substitution method in section 5.2. 10 minus 4 is 6, and so we have our two answers, 4 and 6. We just need to do that last step where we say how 4 and 6 are measured, and then tell me which one is the 4 and which one's the 6. Okay, you can see here that 4 and 6, because those are the variables, they are pounds. And so we have 4 pounds and 6 pounds. Which one is which, though? In other words, which one's the 85-cent T and which one's the 90-cent T? Since x is 4 and since x is the 85 cent, that must mean that the 4 pounds is 85-cent T. You just say 85 cents there. Then I'll know that you understand the difference. 6 pounds then must be the 90-cent T. Okay. So there we go. So that is, again, what happens there when you are buying two things together and you're purchasing them both at the same time, or they give you the total bill. This is the approach you take. It's very similar to the last problem, even though you're not literally mixing these together, okay, like you would mix together candy inside of a bowl of candy, for example. Okay. I'd like you to try the next one here. Let me just get you off to a good start here, though. It says Alan bought each of his 5 nieces a gift, either a DVD or a CD. Each DVD costs $14.99. Let's talk about that for a minute. The word each is the same thing as per, okay, basically. In other words, when they say each DVD costs $14.99, what does that mean? That means that it's $14.99 per DVD. And when they say each CD costs $13.88, what does that mean? That means that it is $13.88 per CD. Okay, so we have two different things that we're looking at in this problem. He's going to buy both of them together, just like in the last problem. Two different things that have a cost per attached to it. Cost per DVD, cost per CD. Okay, he's buying them both together. And so also, like the last problem here, it gives the total cost of everything. He spent a total of $70.51. Just like right here, Trang spent a total of $8.80. All right, so it's basically giving you the same information that the last problem did. Okay, so go ahead and give it a try. Okay, and hit the play button and let's see how you did. Okay, so steps 1 and 2, it says we need to determine, of course, what we're trying to find. It says how many DVDs and how many CDs did he buy. So you can see I set up my variables as usual here. And so then I've got my thing here where I've got my formula on top. I picked this formula because we are, again, buying two different things here that have a cost per attached to it, cost per DVD and cost per CD. We're buying them both at the same time. And I know we're buying them both at the same time because it said he spent a total of $70.51. So that proves that he bought both the DVDs and CDs together. Okay. The two things we're looking at together that are being bought together are DVDs and CDs. The two things that you're buying together always go in these first two rows when you're doing this kind of problem. And then the together row again at the bottom. Okay. The DVDs and CDs together. All right. Kind of like you're mixing them, even though we're not literally mixing DVDs and CDs the way we mixed the candy earlier. Okay, now since it is cost per CD and cost per DVD, that's the type of problem you have, then that's what would go in the middle. But remember, if it's cost per DVD, then this first box right here is the number of DVDs. Cost per DVD here means the number of DVDs here, at least for the DVD row anyway. Okay, and we know the number of DVDs is X, and that's why I put that there. Since the problem also talks about cost per CD, okay, then that means that next to that is going to be the number of CDs. Since this is the CD row, okay, cost per CD would go into the second box right here. And so therefore you would put in the first, I'll do the first column here first, but we know that the second column has to be cost per. And so since for the CD row, it's going to be cost per CD right here, this then must be the number of CDs. Thus, we put Y here. And then why did I put 5 here? It's because he said he bought each of his 5 nieces a gift, meaning he bought one gift for each of the 5 nieces. And so therefore, it's a total of 5 gifts he bought altogether. So between the DVDs and CDs, he bought a total of 5. The cost per goes in the middle, as you know here, middle column. So I put that here. Once again, this is blank. It won't always be blank, as you've already seen. Okay, but it is blank here because, number one, they don't tell us the cost per item, cost per gift for both the DVD and CD together here. All right, this is the together row, and there's not like one single price for a particular item when you put the two items together. Okay, some of them cost this much and some of them cost this much. And so there isn't a number for that. We also don't have a variable for it, okay, for this box. And so, again, third row, second column, if you don't know what the number's equal to and you don't have a variable for it, okay, you can leave it blank. That then brings us to the last row. Again, you can multiply across for the same reasons we did before on the first two rows, But then this last box, again, don't try to multiply across. Even if you were able to, don't try to do that if you already know what it's equal to. And we know that it's equal to 70.51. And so therefore, that's why I put that in there. That leads to two legitimate equations here, and those equations are first column, x plus y equal to 5 right here. Third column, again, don't do the second column. Third column right here, okay? I then solved the resulting system here. I went ahead and got x by itself here, although getting y by itself is perfectly fine as well. If you do what I did though and got the x by itself, it comes out like this right here. You plug it into the other equation. Okay, I distributed You see calculators are even more important than ever right here. The decimals are getting even bigger. And then I combine like terms after I distributed out the bracket. I then move over the 7495 with the 7051, and I end up with this right here. I then divide out to get the y by itself, and that is exactly equal to 4. Y equal to 4. I then plug the y equal to 4 back into this equation right here. And then that gives me 5 minus 4 equal to 1. So what does 1 and 4 mean? Well, since the y is the number of CDs, which you can see over here, since y is the number of CDs and y is 4, that's why I said 4 CDs. Okay? Since 1 is X and X is DVDs, then that means there's 1 DVD. Okay. There's no unit of measurement here like there normally is, like a 1 foot or 4 feet or 1 ounce and 4 ounces. It's just 1 DVD and 4 CDs. Okay. And so that's all you have to say there. All right. So these last two problems are also problems where you bought two things together, but they're a little bit different. Let me go back to a clean sheet of paper here. They're a little bit different, and the way that they're different is that we're going to need, and we've seen this in previous videos before, we're going to need to go back to the problem to find a second equation here. The boxes don't always give you all the equations that you need. Okay, an example of that was back in the motion problem video. Remember where we set up the boxes and we were able to come up with one equation from the boxes here in this Toledo-Cincinnati problem, but I wasn't able to come up with a second equation, and since I needed a second equation for my two variables, I then had to go back into the problem and I found a second equation right here where it says 15 miles per hour faster than. Okay. Sometimes you're going to have to do that. Sometimes the boxes do not reveal all the equations you need. Usually they do, but there's a few problems where they don't. Let's take a look. Number 7. At a movie theater, the price of admission for a child was $3 and $7.50 for an adult. 10 more children than adults were admitted, and the total amount collected was $187.50. So that $187.50 number, you guys, very similar to the previous two problems where it says the total amount of money spent for both the children and the adults. Okay, just like up here, this is the total amount of money spent for both the DVD and the CD. Okay, so two different things that have a cost per attached to it, and then the total cost of both of them together. Okay, so the tickets for both the children and the adults, the movie tickets for both of them, are all going to total up to this. All right, so this number is going to go in the same place as the 7051 did, and also the 880 cents. It's going to go in the bottom right hand corner because it is the total cost altogether. Anyway, the question they're asking here is find the number of children and the number of adults that attended this movie theater. Let's take a look. So the first two steps, as always, what are we trying to find? Attach a variable to those things. Okay, what we're trying to find is the number of children and the number of adults. Okay. So we're going to need two equations, right? So let me set it up. Once again, since we are buying two different things together at the same time, and again, I know that I'm buying them both at the same time together because it gives me the total cost of everything, $187.50. Okay. Since that's the case, we are once again going to use this thing right here because, again, it's not just two things bought together, but two things that had a cost per attached to it. $3 per child, $7.50 per adult. Okay. And so, therefore, the two things that have the cost per attached to it, the children and the adults, those are the first two rows. Okay. and then together. We're not mixing them together. We don't mix together two different groups of people, obviously, but we're buying their tickets both together. All right, the children's tickets and the adult tickets. So, since we have $3 per child, and since we're in the children's row right here, per child would then go, cost per child would go here. That means that since it's cost per child, that means we need to put the number of children here. Okay, and the number of children is X. Since for the adult row, it's the cost that we have is cost per adult. Since that means that we're going to put cost per adult right here. I'll write that down in a minute. But that means that when you put cost per adult here, you need to put the number of adults here, which is Y. Do we know the total number of children and adults together? No, we don't know that. Okay, they don't tell us that this time. And we don't have a variable for it. We've already used that up on these two boxes. So like I said, if you don't know what this is equal to, and you don't have a variable for it, you can add down. Again, don't try to combine like terms, or don't try to combine terms because they are not like terms. All right, so just say x plus y. That's all that I can say because I don't know what this is equal to otherwise, and I don't have a variable for it either. Let's keep going. Next row. Do we know the cost per child? Yeah, $3. Do we know the cost per adult? Because this is the cost per row. Yes, it's $7.50. Notice that both of these numbers are in dollars. Okay, it's not like that problem where some is in cents and some is in dollars. Since they're both in dollars, I just go ahead and keep it that way. No need to convert it to something else when they're all the same. They're both dollars. This one down here is going to be blank for the same reason as it was in the last two problems. Okay, they don't tell us what it's equal to. The cost per ticket for the children and adults together. We don't have one single number for that, and also we don't have a variable for that. Okay, again, some of the tickets are $3, some of them are $7.50, so we don't have one number for all of the children and adults together. Okay, it just depends on whether they're a child or whether they're an adult. So you can't just have one number here. And then in the last column here, again, we don't know what the first two boxes are for the same reasons as before. And so I need to multiply across in order to fill those in. But I do know what this last box is. So since I know it, I need to put that in there. And there you go. Again, $187.50 like we said. Okay. In the previous couple problems, I just added down on the first and the third column, and I had my two equations, and everything was fine. The problem in this case, though, is you can't do that with the first column. I can't say x plus y equal to x plus y because that is an identity. Two sides of the equal sign are just the same thing. They're identical. So I can't do that. But I can still do the third row, however. So let me write that down. It's just that I need another equation now. I've got one right here. I need another one. So like I was telling you with that Toledo-Cincinnati problem from the motion problem worksheet, sometimes you need to go back to the equation, or back to the words up here to find a second equation. Look at this right here. 10 more children than adults. As we mentioned back when we talked about basic application problems, and we talked about that more than thing, we said that when something is strictly more than something else, okay, not more than twice as much, but just more than, okay, well, for example, if something is 5 more than something else, or if something is 7 more than something else, okay, that's where this applies. Let's take a look at how that compares to what we're looking at in the current problem. It says 10 more children than adults. Doesn't that mean that the number of children is 10 more than the number of adults? Okay, there's 10 more of the children than the adults. So when something is more than something else, we put the smaller quantity out of the two things that are being compared. Okay, when we say that there's 10 more children than adults, we are comparing the number of children to the number of adults. aren't we? Okay, 10 more of the children. All right. So you take the smaller of the two things that are being compared, which is the adults. The number of adults is y. Write that down. Okay. And it says here to take that y right here. Okay, the smaller quantity is y. I'll go ahead and just write down y on this as well. Y right there. Plus, and then what's the difference between the two quantities? 10, right? Because it says 10 more. 10 more children than adults. So y plus 10 is equal to the larger quantity. The larger quantity is going to be children because there's more of the children than the adults. And since x is children, then the x then would go here. So adults plus 10 is equal to children because there's 10 more children than adults. All right, smaller goes here, larger goes here. So y plus 10 equal to x. Let's write that down. And now we have our two equations. Okay. Since x is already by itself, we might as well use substitution method here, okay? Because if one of the variables is already by itself, all you got to do is take what it's equal to and plug it back into the other equation. All right, let me do that now. And then solve that equation. So they already did the work of getting the one of the variables by itself. All right, so you just have to plug it in right away. I now distribute. Okay. Then I combine like terms. 3 plus 7.50 is going to be 10.50 on your calculator. Okay. Then I move over to the 30. Let me just rewrite it here. But yes, I'm going to move over the 30 with the 187.50. So that the y term will be by itself. And so I get 10.50y is equal to 157.50. And now I divide out now that I have the y term by itself. Y is exactly equal to, on your calculator, 15. I then plug it back into that equation at the beginning of the substitution method, the one where you plug it into the other equation. That one, like I always do when I do substitution. And in this case, I get 15 plus 10 is 25. So since my two variables are equal to 15 and 25, I bring those over here. 25 is x, and since x is the number of children, we have 25 children. There's not a unit of measurement for that. They're just children, okay? There's not feet or miles or inches or any of that kind of stuff. 15 is the number of adults, so we just say 15 adults. And there you go. So we just had to go back to the problem, okay? And that happens, again, you have 5 different ways to create equations here when you have the 3 rows and the 3 columns. There's 5 different ways to use the boxes to create equations. You could either do this times this equal to this, but again, that creates an identity. You could do that same thing with this row or this row where you go first times second equal to third. But again, that creates an identity. This creates nothing because you don't have anything in the middle here. The other 2 ways besides those 3 ways of going across is to go down on the first and third column. This one again creates an identity. And so that leaves you with this column as the only way out of the 5 ways to come up with an equation. And that's why we had only one equation that was created from the boxes, okay? And so therefore we had to go back to the problem to come up with a second equation. Now, Just a reminder, you guys, I don't want you to get confused. When we have the problems that have only 2 rows, like we did in the motion worksheet, okay, don't be doing any adding down stuff. No, no, no. There isn't a third column. There isn't a third row there to add into. Okay, remember the adding down means that you what? You go first plus second equal to third. Well, there isn't a third row here, so there's none of that adding down stuff. Multiplying across, yes. Or in the case of these downstream upstream problems, dividing across. But either way, you can go across still when you're doing these 2-row problems. You just can't go down, okay, because there's not a third row to go down to. Just want to make sure that we understand the difference. Okay, last problem. I'd like you to try this, and you're going to see it's very similar to the one we just did. At Vern's Grill, hamburgers cost $2.70 each. What does that mean? That means $2.70 per, when it says each, it means per something. Per what? Well, they're talking about burgers, so it's going to be $2.70 per burger, right? $2.70 per burger. Okay. Bag of fries costs $1.20. Okay. That means it's $1.20 per bag of fries. So again, we have 2 different things with a cost per attached to them that somebody is going to buy together as all one purchase. And you'll see that right here in the next sentence. It says how many burgers and how many bags of fries can a customer buy with $26.40. So in other words, he's going to spend the $26.40 on both the burgers and the fries together. And so once again, the $26.40 is going to go into this box down here on the bottom right-hand corner because it's going to be the total cost of all the burgers and fries together. Okay. Now here's what's different though. It says if he wants twice as many burgers as fries. We haven't talked about this yet. Let's go back to the basic application worksheet. We talked about it a little bit in this worksheet, but we haven't seen it since. If one quantity is, for example, 3 times as large as another, you go 3 times the smaller equal to the larger. So once again, the smaller goes with the number. The larger is over here on the other side by itself, on the other side of the equal sign. But this time, because it's 3 times, you go 3 times the smaller. You don't go 3 plus like we did up here. It's 3 times. But that's when it's 3 times. Okay? If it's 2 times as large, then it's going to be 2 times the smaller equal to the larger. If it's 4 times as large, it's going to be 4 times the smaller, for example. Okay, what is this? It says twice as many. Doesn't that mean 2 times as many? And so 2 times as large. There's 2 times as many burgers as there is fries. What does that mean? It means that you're comparing the number of burgers and the number of fries that you're buying, okay, and the number of burgers is 2 times as large of a quantity, okay? We're not talking about the size of the burger. That has nothing to do with it here. What are they comparing here when they say twice as many burgers as fries? They are comparing the number of burgers you buy to the number of fries that you buy. And so, which one's bigger, the number of burgers or the number of fries? Okay? The number of burgers is bigger because it says that there's twice as many burgers. And so that means that you put whatever the burgers is equal to. It's going to be a variable. Okay, whatever one you pick, you put the burger variable here. You put the fries variable here because that's going to be the smaller due to the fact that there's twice as many burgers. And then you put 2 right here. Okay. By the way, this only works if this number is like 2 or larger. It doesn't work like if it's like half times, okay, or 1/3 times. It's only for when the number is like 2 or 3 or 4 or something bigger than that. Just to let you know, okay. But here it is 2 times as large, twice as many, the same thing. That means the same thing as 2 times as much. And so you can use that formula there. So again, from this worksheet, all right, 2 times the fries variable equal to the burger variable. Go ahead and try that. Hit the play button, and let's see how that final problem comes out. Okay, number 8. So, the thing that we're trying to find is the number of burgers and the number of fries. It tells us right here how many burgers and how many fries. So we know that that's what we're trying to find. Got my two variables set up. Okay, again, we are trying to look at a problem here where they are purchasing two different things with a cost per attached to them both at the same time. Okay, $2.70 per burger, $1.20 per bag of fries. Okay, so that's how I know that. Again, for the burgers, the cost per burger is going to go in the middle. That means the number of burgers is going to go here in the first box, and the number of burgers is X. For the fries row, okay, the cost per bag of fries will go in the middle, and so that means the number of bags of fries goes first, and you can see that that's Y. Once again, we do not know the total number of burgers and fries together that they bought. We don't have a variable for it either because the variables got used up here. So the only thing I can do is just add down to fill that in. Just like on the last problem, it's X plus Y. In the second column, I put in the cost per burger for the burger row and the cost per bag of fries for the fries row. Okay, and again, for the same reasons as in the last three problems, I don't fill in that last box. In the final column, just like we've seen here, in the last three problems, the first two boxes, the only choice you have is to multiply across. All right, but then this last box, we already know what it's equal to, so we need to put that in there, $26.40. Total cost altogether for both items, burgers and fries. So the only option we have is to use this as an equation. We can't use X plus Y equal to X plus Y. We can't use this first row. We can't use this second row. We certainly can't use the third row because there's a missing box there. Okay, all of those other things give us an identity except for this one right here, which doesn't even give us anything because of the missing box. The only thing that gives us a legitimate equation is this third column. And so I wrote that down. So we need one more equation due to the fact that I have two variables. I need a second equation. Okay, that's where this thing comes in again, where it says twice as many burgers as fries. So let's go back to that sheet that I was showing you. Okay, if something is 2 times larger than something else, all right, then you look at the two things that are being compared, which is the number of burgers and the number of fries. All right, the number of burgers is the larger one, and so we put that here, X, and we put the 2 here since it's 2 times as much, not 3 times as much this time. And then the smaller of the two things being compared is the number of fries, number of bags of fries. You can just say number of fries for short, and that's Y. So it's going to be 2 times Y equal to, bring down the equal sign, 2 times Y equal to X. And that gives me this equation right here. 2 times Y equal to X. Now, since the X is already by itself, I'll do substitution by just substituting the 2Y into the X in the other equation here. Now, remember, when you clear out the parentheses, you guys, if your parenthesis has only one term in it, don't distribute to multiple parts, okay? You're supposed to distribute to each term. That's why I had 2 multiplications, like I normally do, when you got 2 terms inside of the parenthesis and you're distributing on that first step. Okay, but since this has only one term, you just multiply by it. You don't distribute to more than one thing there. So you just multiply by 2.70 times 2y. That gives you 5.40y. Okay. I then combine like terms and I get 6.60. Sorry, it's hard to see that. 6.60y equal to 2640. I then divide out by the 6.60. 26.40 divided by 6.60 is exactly equal to 4. Okay. And then we then plug it back into the equation that I plugged in at the end of the first step of the substitution method. Okay, like always. And I get 2 times 4 is equal to 8. 8 burgers because X is 8. And 4, you could call them bags of fries or just call them fries. I'll understand what you mean. Okay, 4 fries, 8 burgers. Okay, so that is number 8. Okay. and therefore we're done with the mixture worksheet. All right, we had 2 different videos for it. This is now the end of the second video. Before we go, just like we did at the end of the first video, want to look at just a few problems to help you get off to a good start with some of these, because there's some, as you know, with word problems, sometimes things are worded a little bit differently from one problem to the next. So just want to make sure that we go over some of these things. The first problem that you're going to see for these types of mixture problems anyway, the ones with the, you know, where you got the 2 different things with a cost per attached to them. The first one you're going to see here is this one right here. All mixed up nut shop sells a mix consisting of cashews and pistachios. How many pounds of cashews, which sell for $7 per pound, should be mixed with 4 pounds of pistachios, which sell for $4 per pound? To get a mix worth $5 per pound. Please notice that this is a little bit different than the problems that we looked at for the most part, because it actually tells you, see, in the problems that we looked at here in this video, they always asked you how much of each of the 2 things that you're mixing, how much of each one do you need? Well, this time they tell you how many of the pistachios there already are. Okay, so instead of having, like we did all throughout this current video, instead of having, let me just write it down here real quick. Instead of having X and Y right here, you're now going to have X and 4. Because they already tell you that this one is 4. If this is the pistachio row, this is the cashew row. All right. It's going to be X and 4. I just want you to be aware of that because it's different than the other problems that we looked at. Okay, so I didn't want you to get thrown, especially since that's the first problem from these types of mixture problems that we're looking at here. Okay, but they are just looking for one thing there. There's just going to be one variable, so you only need one equation in that particular problem. Okay, so as it's going to turn out, they don't tell you what the how many pounds are in the mixture, so you're going to add down, okay, and I'll let you go from there. But you're going to take this, all right, fill in the rest of the rows, and then you will be able to come up with that one equation that you'll need for that, okay. Because they do tell you what the next row is equal to, all right. It tells you how much per pound for all 3 of these things here, including the mixture, and then you can multiply across in order to figure out the rest. Okay, and then you can come up with an equation from what you see there. Okay, so go ahead and try that. One other thing I wanted to show you, and it's in another section here, which is going to be part of your assignment. Again, nothing unusual on this one, just want to make sure, because it's a little bit different than how this problem that we did is worded. See where it says Oscar purchased 16 stamps. He bought some that are $0.44, same thing as 44 cents, and some that are $0.28, and he spent $6.48. Notice that they're all in dollars here, no cents. Okay, we say $0.44, but when you have a dollar sign, that means that this decimal is just a dollar amount. When we say $0.44, that's just the way we word it in everyday life, but this is a dollar amount. These all are dollar amounts because they all have dollar signs next to them. Okay, so I just want to make you aware that that is very similar to the DVD CD problem, okay, where instead of buying 5 gifts, he bought 16 stamps, okay? He bought 5 gifts. This guy bought 16 stamps. Some of them are a certain price. Some of them are a different price. And then the total cost of everything was $6.40. Okay, how many of each did he buy? All right, very similar type of thing, okay, to that CD, DVD problem. Okay, so that concludes, again, the mixture worksheet. All right. You have a good day. You take care. And as usual, you guys, let me know if you have any questions about this. All right, and we'll see you back for, we got a couple more videos left. When we come back next time, we will talk about interest, like the kind of interest that you see when you invest at a bank or borrow something from a bank. Okay, so that'll be next. Take care.